So on the first one, you guys know this part, right? Oops. We need to circle our variable and draw the line. We're going to keep doing that all the way through the end of the school year, so make sure you're not forgetting that. It's always going to be part of the work that we're looking for. We want to get a by itself, so we have to get rid of the 7. How are we going to get rid of that? Subtract 7. So we subtract 7 from both sides. On the left side, those 7's cancel, leaving the a. On the right side, we have a positive 3 and a negative 7. So since we have positives and negatives, they're going to cancel, and what's going to be left? Negative 4. All right, so there's 4 more negatives than there are positives, so we get negative 4 there. All right, the next one, kind of similar. We want to get the b by itself. We draw our line through the equal sign. This time we want to get rid of that 13 by doing what? Add 13. So we add 13 on both sides. And again, we can see here that we're going to have some positives and negatives because we have the positive 13 and the negative 2. So these negatives here are going to cancel out with some of the positives here, and what's that going to leave? 11. Okay, we're just doing 13 minus 2. And it's positive because 13 is positive, that's the bigger number. All right? These two we're going to have to multiply and divide. What do we need to do here to get the c by itself? Be careful that you don't add. Some people want to add 3 here. But this is not a subtraction problem, right? It's a multiplication problem. So to get rid of it, we're going to divide. What do we divide by? Negative 3. Make sure you divide by the number that's being multiplied by. So we're multiplying by negative 3, so we divide by negative 3. All right, so we divide by negative 3 on both sides. And the negatives and the 3's cancel and leave what? On the left side, c. And on the right side, we have a negative divided by a negative gives us a positive. So 21 divided by 3 is 7. So I like to do this and just show that the negatives basically just cancel each other out. That way I don't have to worry about them and I get 7 for my answer. All right, next one we want to get d by itself. So we circle the d, draw our line of equality, and to get rid of this 5 here, what are we going to do? Multiply. So we multiply by 5 here, we multiply by 5 here, and 5's cancel, leaving d all by itself, and 5 times negative 5 is? So 5 times 5 is 25. Is it positive or negative? It is negative because? Is it because the bigger number is negative? No. Yeah, anytime we multiply by a negative, the answer is going to be negative. Okay, unless it's a negative times a negative, then it would be positive. All right, here are the fun ones, right? The new ones. So we started out the year with solving equations. Then we did some operation stuff with fractions last week. So now we're going to put those two things together. So solving equations, we still circle the variable and we still draw the line. Okay, that's no different. And we still have to use inverse operation. So we have to do the opposite operation than what's in the problem. So we have e plus 1/3. So how do we get rid of that 1/3? We subtract 1/3. So we put minus 1/3 on both sides. And on the left side, those 1/3 are going to cancel each other out, leaving what? E. On the right side, we're going to have to do a little math, right? Why can I not do 3/5 minus 1/3 right now? The denominators are not the same. We need to get a common denominator. So what I'll do is I'm going to just write this problem down below. So we have 3/5 minus 1/3. And what denominator should we use for these two fractions here? 15 would be the lowest one. So let's go with that. So we're going to change that to something over 15 minus something over 15. That's a 13. All right, what do I multiply by 5 here to make this a 15? 3. So I have 3 times 3, which is 9. And then what do I multiply this by to get 15 on the bottom? 5. So I have 1 times 5 gives us 5. So now what we have is 9 over 15 minus 5 over 15, which is, once we get a common denominator, then we can just add or subtract, right? So are we adding or subtracting here? Yeah, we subtract and get 9 minus 5 is 4. We keep the denominator the same and we get 4 over 15. And I'll just put a box around it and I'm done, right? Of course not. Where do I put that? Yeah, I need to put it up here in this equation. So the 4 over 15 is what we get when we subtract these, so I'm going to put that in here. Alright, this is kind of like some of the ones that we did with some of the bigger numbers for like multiplying and dividing, where you might have to do a little bit of work for solving the equation off to the side. Alright, you could also try to do that up here. There's no reason you can't do that if you want to. So you could write 3/5 minus 1/3 out to the side here and then get a common denominator and subtract. And you could do that work up in here also if you wanted to. Alright, last one, we want to get f by itself. So I'm going to circle that, I'm going to draw my line of equality. And what do I need to do to get rid of that 4/9? Divide. So we have multiplication here, right? So the opposite of multiplication is division. So we're going to divide. So I'm going to show that by just writing over, write it over 4/9. So we're dividing by 4/9. And remember, we need to do that on both sides. Now, this doesn't look like a lot of the division problems we've done with fractions, but it's still a division problem, right? And what do you guys remember about dividing with fractions? Can we do it? No, you can't divide fractions, so we have to change it to what kind of problem? Multiplication. All right, and what was the acronym that we used to remember what to do for changing it to a multiplication problem? KFC. So we're going to do our KFC step first. Again, I'm going to write this underneath. So I'm going to keep something. That's the K. What do I keep?
2/5.
The 2/5. The first one I keep the same. So 2/5 stays the same. I'm going to, what does the F stand for? Flip. So I'm going to flip one of them. Which one do I flip?
4.
The 4 over 9. So I flip the one that we're dividing by and make that 9 over 4. And then the C stands for change what? The division to multiplication. Alright, so what we've got now is 2/5 times 9/4. And then we multiply. Now, I'm not going to multiply across yet. I'm not going to get 18 over 20. I'm going to do something else first. What can I do first so that I don't have to reduce later? Well, I can simplify now, right? Remember, when we multiply, we don't need a common denominator, but we want to simplify if we can. All right, so what can simplify here? Are there any numerators that'll simplify with any denominators? The 2 and the 4. So let's reduce that. What goes into 2 that also goes into 4? What goes into 2 that also goes into 4? 2. What's 2 divided by 2?
1.
What's 4 divided by 2?
2.
Okay. Is there anything else that will reduce? Can that 9 reduce with the 5 since they're both odd? No. Okay, there's nothing that goes into 5 that also goes into 9 except for 1, and we'd never want to reduce by 1 because that doesn't help us. So now we multiply across. 1 times 9 is?
9.
And 5 times 2 is? 10. And can I reduce 9 over 10? Just want to check real quick. No, we can't reduce that, so we're done, except just like the last one, we need to write our answer in the right place, which would be where? By that F. Okay, so just like the last one, there's a little bit of work that we needed to do outside of the equation, off to the side, just to help us get the answer, but then we always want to make sure we write our answer up here with the equation.